On December 8, 1941, Pearl Harbor lay in ruins. On that day, America declared war on Japan. And on that same day, in a little field in Bridgeport, Connecticut, the American helicopter came of age. A young pilot, Charles Lester Morris, climbed into the seat of the world's first workable single-rotor helicopter, the Sikorsky VS-300. A new control system was about to be tested, a full cyclic pitch main rotor to control direction of flight, and a small vertical tail rotor to swing the helicopter on its axis, a control system still used in 90% of present-day helicopters. After a few seconds, it began to rock in the air, and Morris was forced to set it back down on the ground. For the helicopter's designer, Igor Sikorsky, the flight must have been a disappointment, but within a month, the VS-300 would be flying beautifully. Igor Sikorsky was born in Kiev, Russia in 1889. He grew up in a home full of books and conversation. He read works of Jules Verne about balloons and vertical flight machines, and listened to the fireside stories told by his mother. Legends of Icarus and Bucephalus, the legends of flight.
I think the legend of the helicopter goes back a very, very long way, because there's no doubt about it that man has dreamt of flying for hundreds of thousands of years, created legends of the flying carpets, the flying thrones, Pegasus, Bucephalus. All of these dreams, interestingly, had one thing in common. All of them were vertical takeoff and landing machines. None of these required a runway. And I think it was with dreams such as these that my father grew up, and that's where this lifelong love affair with a helicopter started.
It was said that Leonardo da Vinci experimented with air screws like that. A number of other people tried to build helicopters. I myself attempted to build two in 1909 and 1910.
These two crude helicopters were inspired by stories of the Wright brothers and a visit to Paris in 1909, where Sikorsky met and talked with some of the most famous French aviators of the day. But while Sikorsky's passion was for vertical flight, Russia at the time needed fixed-wing aircraft. Sikorsky became an airplane designer. His success was immediate. And then the power of his ambition began to show. He designed and built the world's first four-engine aircraft and called it, appropriately, the Grand. He learned to fly and became his own test pilot. In 1917, the Russian Revolution came, and with it, the great emigration of white Russian refugees. Igor joined the flood. But New York in 1919 was by no means the promised land. Times were tough for refugees, and there were no opportunities for a white Russian aircraft designer. Ironically, it was a group of other white Russian immigrants who helped him.
It was a number of these white Russian refugees eventually, who of course had all heard or had known of my father's work in Russia, that convinced him to try again. And they all pooled their money, and it was with a very significant amount of $800 in cash that they started work in the backyard of a chicken farm just outside of Roosevelt Field on Long Island. These 12 or 14 Russians actually donated their labor. They worked for free and started the company. At a very critical point, just as they had it nearly completed, they ran out of money. And it was then that a very great Russian composer and concert pianist named Sergei Rachmaninoff came to the aid of this struggling company and gave at that time, the very significant sum of $5,000.
In the early 1930s, Sikorsky joined forces with transatlantic hero Charles Lindbergh. Lindbergh's energy was now directed at international travel, and the large Sikorsky flying boats were just right for exploring potential airline routes across the oceans of the world. There was no time for Sikorsky's first love, the helicopter.
While this is underway, it would not be wise to start something new, because it is not. Helicopter was not a project which I put just to charge to the engineers to do something about, and to test pilot to test and to do something about it also. It was a thing which called for attention, I would say love, I would say all energy, knowledge, and support which a man can put in.
Even so, the helicopter was never far from his mind. In 1931, he successfully patented a single rotor design. Young Sergei Sikorsky did what he could to help.
I was already growing up. I remember very, very clearly building small balsa wood models of these helicopters for my father's use in demonstrating them, first of all, to his own engineering people, many of whom, mind you, were very skeptical of the idea of abandoning the flying boat and getting into the helicopter.
But by late 1939, Igor Sikorsky had built and was attempting to fly the first crude form of his VS-300 helicopter.
You climb aboard this machine and you start up the engine and you try to fly it, never having flown a machine before in your life. So quite literally, at the age of 50, he went back and was retracing those same pioneering emotions that he had had at the age of 19, 20, and 21 when he built his own airplane without knowing how to build it, and then climbed aboard and tried to teach himself to fly while he was test flying this aircraft.
Igor Sikorsky was once again entering new territory.
In addition to all of this problem of literally walking out on very thin ice with a totally new and untested principle, was the very minor problem that Igor Sikorsky had never flown a helicopter before in his life. No one had. So first he had to teach himself to fly the machine.
The VS-300 had a cyclic pitch main rotor and a vertical tail rotor to control direction. But learning to fly it wasn't easy.
You had to lift the aircraft off the ground, teach yourself to hold it off the ground, say a foot or 2 or 3 feet off the ground, and then teach yourself how to be able to control the machine so that it stays within more or less 1 or 2 feet. That was the secret. Later, the challenge of slowly increasing forward flight called for another set of solutions, called for another set of redesigning of the main rotor head, called for nearly another year and a half of very hard, difficult work.
Part of this delay was caused by an incident on December 9, 1939. Serge Gluarev was the pilot. Stability and control were still very limited. A simple, unexpected gust of wind was too much to deal with. Serge Gluarev was not injured, but the VS-300 was, and Igor Sikorsky decided on another approach. He replaced the cyclic pitch control with 2 small horizontal rotors. Unequal pitch change on these rotors would roll the machine left or right. Equal pitch change would lift or drop the tail. It appeared to work quite well, and in March 1940, it was tested in flight. Sikorsky made many flights of 20 minutes or more, and quickly learned to hover it, or move it backwards or sideways, but the controls were still uncertain. The first public demonstration, with Igor Sikorsky as pilot, underlined a weakness of this control system. While a hover was reasonably controllable, in forward flight, downwash from the main rotor disturbed the rear rotors and caused instability. Controlling the machine was very difficult, and often a quick return to the Earth was the only safe course.
I remember one of my father's closest friends and cohorts on the helicopter project, also a white Russian refugee with a rather intriguing accent, saying, "It was very interesting time. It was time of educated guess and crystal ball." And that's the way the helicopter was designed.
Igor Sikorsky now set out to analyze and cure the forward flight problem. On October 9, 1940, after weeks of test flights, he was making a series of forward runs about 20 feet above the ground when one of the rear pylons snapped away. The VS-300 crashed again. Igor, unhurt, stood for a long moment looking at the wreckage. Then he said, I think I'll get her home now.
You really never knew whether it was the machine, whether the design was at fault or the test pilot was at fault. But I remember Dad with a grin in his eye saying, since both responsibilities were concentrated in one person, namely myself, I couldn't put the blame on anyone else. And I had to accept it, repair the machine, and carry on.
He did. And he got on with the task of refining the design and making it work. The pylons were swept back, and the tips raised to get them out of the downwash. The torque rotor was also raised on its own new pylon. In April 1941, Igor tackled the world helicopter endurance record with the VS-300 in this configuration. Igor Sikorsky's new world record was 1 hour, 32 minutes, and 26 seconds. Tests continued on this modified T-bone layout. Forward flight was now possible, and its controllability was greatly extended. Earlier in 1941, the Army Air Corps had been impressed enough with the helicopter to order a two-place version, with this control system to be called the XR-4. The encouraging performance of the VS-300 brought Igor Sikorsky closer to a long-held dream: to build a vehicle that could go anywhere, regardless of terrain, and set itself down in confined spaces on land or water, something that would give, in Igor Sikorsky's words, unlimited freedom of transportation. At the time, the helicopter's potential to do things no airplane could do was not always obvious.
I remember a good friend of mine and a very prominent designer, scientist and aviation asked, when would the helicopter go faster than the airplane? Do you know that? I said, yes, I know. The answer is never. When would the helicopter be more efficient than the airplane? Do you know that? I also said, yes, I know that. Never. But I said that helicopter will do a number of jobs which no airplane will do, and which in fact nothing else will do except a helicopter.
Charles Lester Morris made his first flight in the VS-300 in May 1941. Because of the difficulty of forward flight, he spent most of his time learning to hover and move backwards and sideways. In 1987, Les Morris spoke about those pioneering days and the need for Sikorsky to make major changes if the VS-300 was to be truly flyable.
So early in the summer of 1941, the decision was made to return to cyclic pitch control in the VS-300 helicopter. It would be so much simpler than having those awkward and cumbersome tail rotor outriggers. We would try to do it in two stages. First, we would get rid of the outriggers, of course. Then we would use cyclic pitch control just to the lateral control of the machine, rolling it left and right. And for longitudinal control, we would use a single horizontal tail rotor mounted on a tower high above the tail, well out of the downwash air from the main rotor. In early August, we rolled the machine out with this new arrangement, and there were a lot of adjustments and changes to be made. But on August 14th, 1941, remember that date, we suddenly discovered in one day that we had a completely flyable helicopter. All in one day.
Les Morris's first flight with the new control layout was a revelation. He was able to do forward runs of 70 miles an hour, quick stops, backup, and do things they'd only dreamed of with the old system, and no problems developed. Even so, Igor Sikorsky decided that this was not the right control system for the new Army helicopter, the Sikorsky XR-4, and since the VS-300 was the test vehicle, it would be modified to test the next stage of control development.
So the beautiful, flyable little VS-300 was once again torn apart. The tail tower was removed, and the rotor hub was realigned for full cyclic pitch control. On December 8, 1941, the day that the United States declared herself at war with Japan, we rolled the ship out for the first trial.
After the elation of his previous flights in the VS-300, Les Morris's first experience with the cyclic pitch version was a disappointment. This flight introduced doubts into the minds of the whole team, and they had to back off the test program to analyze the situation. What was wrong? Was it part of the rotor system, or was it something to do with the whole design? Some months earlier, the oil dampeners, or oleo struts, had been removed from the rotor blades, and as it turned out, that was the problem.
The old oleo struts were recalled to active service, but they were installed at the rotor hub in such a way that they would damp the blades in the horizontal plane. Like a miracle from the Dark Ages, they turned the trick. Flights were made forward, backward, and sideward, and no wobble or resonance was detected. Thus, on the last day of 1941, the VS-300 demonstrated another completely satisfactory control system.
At last, they had it right. The classic Sikorsky configuration had arrived. A single main rotor with full cyclic control, and a small vertical anti-torque rotor with variable pitch. Sikorsky's dream of unlimited freedom of transportation was within reach, but he also saw the helicopter as a means of saving lives. Now, with control problems apparently solved, there was no limit to what might be achieved. Igor Sikorsky had indeed taken the chance to live his life over again. For the second time, he had built a flying machine without knowing how, and had taught himself to fly it. This was the final version of the VS-300, the culmination of 3.5 years of development. The name was still the same, but not much else was.
Probably, having lived through much of the development of the VS-300, I can say with some minor confidence that the only pieces of the helicopter that are identical to that first machine that lifted off in September 1939 are the pilot's seat and certain of the structure around the engine. I would dare say everything else was bent, broken, smashed, or modified during the 3.5 years of the helicopter's existence.
And now, the race was on to educate the public and decision-makers about the virtues of the helicopter. Demonstrations of extreme controllability were the order of the day. The wide-open spaces were out. The trick now was to land in the smallest area you could fit. The VS-300 successor, the XR-4, was formally accepted by the Army on May 30, 1942, and went into production as the R-4. As it demonstrates here, even with the power off and auto-rotation, it could come very close to landing on a handkerchief. Igor Sikorsky's helicopters had already begun to change the face of aviation, and he had achieved what the cynics had said was impossible.
Any responsible engineer could prove to you that the single main lifting rotor, and then to steal power from that rotor to drive a small little rudder-type rotor, is improper and inefficient. And yet Igor Sikorsky felt that was the logical way to go. And it's interesting that today, this configuration that was so criticized when he first applied it is the dominant configuration. And in fact, roughly 95% of all of the helicopters in the world built since World War II are built with this same configuration.
Igor Sikorsky died in 1972. He saw 30 vibrant years of helicopter development, and for those years saw how his pioneering work came to change the face of 20th century life. But the helicopter was not his only passion. Like his Renaissance forerunner, Leonardo da Vinci, his interests were wide-ranging, and he was very good at a great many things.
The further away he gets, the more we realize what a great and unique person he was. Not only as an aeronautical engineer, not only as a very, very gifted test pilot, but also as a philosopher, as a historian, as an amateur astronomer, also as a very brilliant archaeologist and historian. I think he could have been a very, very great success in a great many professions. We're just lucky that he chose aviation as his first love.
He was a Russian by birth. He fled the motherland one step ahead of a Bolshevik firing squad. He designed and built the first four-engine airplane, the first airplane with an enclosed cockpit, and together with Charles Lindbergh, cooked up the seaplanes that made international airlines practical. Lindbergh called him the greatest aviation engineer he'd ever met.
He showed tremendous scientific talent at a very early age. By the time he was 11 or 12, he had read how to build small electrical motors, but he couldn't find any in Kiev at that time, so he actually began to take the bobbins from his mother's sewing machine and wrap them with wire, and he created his own electrical motors that he then powered with batteries by taking pickle jars and making batteries out of them.
For all his fixed-wing achievements, however, he is most closely identified with helicopters. For it was the helicopter company he founded relatively late in his life that turned his name into a household word. He is Igor Sikorsky, and he is a legend of air power. Igor Ivanovich Sikorsky was born May 25, 1889 in Kiev, Russia. His father was a psychology professor and his mother a doctor, and together they nurtured their son's early interest in science.
His life was in a home in which he was felt very sheltered, very secure, very happy, in a home in which his father encouraged scientific research and encouraged daydreaming. He read what today we call science fiction books, primarily Jules Verne. He loved Jules Verne, 20,000 Leagues Under the Sea, 80 Days Around the World, Voyage to the Moon. But primarily, there was one book, Robur the Conqueror, also known as, prophetically, The Clipper of the Clouds. And it's very, not too well known here in America, but it's a book that describes a flying machine very accurately, actually a helicopter. Very, very accurately describes a helicopter some, obviously, 40, 50 years before it was ever flown.
He attended the Petrograd Naval College, but left in 1906 to study engineering in Paris, then the center of aviation in Europe. His time in France was a revelation. The Wright brothers were demonstrating their flyer outside Paris. The sky seemed filled with airships, and everywhere there were aeronauts and engineers collaborating on bigger and better flying machines. He returned to Russia and enrolled at the Mechanical Engineering College of the Kiev Polytechnical Institute.
He started pestering his parents to send him to Paris, because that was where the Wright brothers were flying. That's where, immediately after the Wright brothers' success, The Europeans tweaked their airplanes a little bit so as to pick up a little bit of the know-how that the Wrights had demonstrated, and flying exploded in France.
In 1909, armed with an engineering degree, he returned to Paris. He befriended the elite of aviation there and spent much of his time talking about his vision of an aircraft that could take off vertically, hover, move sideways, and set itself safely back down. The experienced pilots around him laughed at his plans. It was hard enough then getting an airplane to simply fly. Getting it to stand still without falling out of the air seemed laughable. Sikorsky announced to his doubting friends that he would return to Kiev and build a rotary-wing aircraft, a helicopter. He bought 2 engines, 15 and 25 horsepower, and boarded a train east.
It's significant to me that his first aircraft and his second aircraft were both helicopters. They didn't fly. We know now that 15 and 25 horsepower is just too little to do it. But these were the first 2 aircraft he attempted. Very wisely, he then decided that he had to, in his words, temporarily postpone the helicopter.
He built a succession of small planes that clearly owe much of their inspiration to the Wright brothers. In only a few years, Sikorsky was one of the leading engineers in Russia. He was put in charge of the aviation subsidiary of the Baltic Railroad Car Works and went to work designing and building aircraft for the Tsar.
He was the first, actually, to come up with the idea of using multiple engines on an airplane. After he had one engine get caught with mosquitoes in the carburetor and the airplane went down, he realized that 2 engines are better than 1.
A multi-engine airplane was a radical idea. Other engineers thought it impossible. If the weight of the engines didn't keep the plane on the ground, they believed the forces and vibration of more than one engine would tear the plane apart in the sky.
During his early years, he developed multiple engine aircraft, 4-engine aircraft that were very, very large, which requires a great deal of skill as an engineer to be able to produce a large aircraft that everything works correctly, especially at the time of the type of materials they had to work with. It was quite an achievement.
Sikorsky continued on, however, and the result was a 4-engine behemoth with an almost unfathomable 89-foot wingspan. Called simply the Grand, when it flew in 1913, it made Sikorsky into a Russian hero.
The Grand was a unique experiment in trying to convince the world that a large 4-engine aircraft was possible. He wanted to build this airplane because he wanted to prove that an aircraft had to have 2 characteristics. The Grand was designed to demonstrate 2 critical elements. A, the element of being able to maintain altitude and continue flight if one engine failed on you. And the second, equally important element, that airplane had to be able to lose any one of its engines, inboard, outboard, any one side or the other, and remain controllable. He, with a twinkle in his eye, would talk about the Grand and say that it was a very unique aircraft. It took off at 65 kilometers an hour, it cruised at 65 kilometers an hour, and it stalled at 65 kilometers an hour. But other than that, it was a highly efficient airplane.
His next plane, the Ilya Muromets, was even bigger and became the main bomber of the Russian Imperial Air Force in World War I. Designing aircraft had made Sikorsky wealthy. He was invited to meet several times with the Tsar, and there was talk that he might be knighted for his work.
When the revolution started, that very fact that he had been recognized by the Tsar and had been rewarded by the Tsar made him an enemy of the working class and made him a target of the Soviet, or the Bolshevik at that time, hit squads.
A committed individualist, Sikorsky could not live under communism and decided to leave. His wife chose to stay and refused to let their daughter travel with him. He left penniless and broken-hearted, a refugee bound for Paris, but destined for the United States. After fleeing the Russian Revolution, Igor Sikorsky tried to find work in Paris.
The World War I was still on in 1917, and so he went to France, where the French aviation authorities knew him very well because that he had purchased during the war a large number of French as well as British engines for his 4-engine bombers. They commissioned him to build a large bomber for them.
But when World War I ended, so did the French commitment to aviation. And with no other option, he sailed for the United States.
My father then spent some weeks studying the situation and then decided that he would go to the United States because he felt that this very, in his words, this very great and wonderful country was probably the only nation which would accept a penniless immigrant with the dream to start building airplanes again.
Though famous in his own country, he was unknown in the United States. He arrived in an unwelcome wave of refugees. There were no opportunities for him in aviation. With World War I ended, no one was building new aircraft. The glut of military surplus biplanes supplied the embryonic commercial aviation business with all the planes it could handle. With nothing else to do, Sikorsky tutored Russian immigrants on New York's Lower East Side. He lectured on math and astronomy and aviation. He lived in poverty, but never let it break his spirit. And as time passed, he built up a following in the large community of Russian refugees. His optimism seemed boundless, and his vision of the amazing future of flight made what were really little more than daydreams seem real.
For a lot of the Russian immigrants, he was something of a hero, something to aspire to, having come here as an immigrant and having all these dreams that he was so anxious to fulfill.
In the early 1920s, Sikorsky resigned himself to the fact that he would never again get to design and build aircraft. Then, in 1923, a group of Russian émigrés approached Sikorsky. They had a small amount of money and were willing to work. Would Sikorsky do them the honor of helping them design and build an airplane? Sikorsky set up operations on a chicken farm next to Roosevelt Airport on Long Island. There, he and his small band of Russian immigrants went to work. There was never enough money for payroll and barely enough for materials. No matter, Sikorsky and his Russians worked through night after night on a large twin-engine airplane Sikorsky had designed. And then, with the plane partially built and a desperate need for high-powered engines to make it fly, Sikorsky and his Russians ran out of money. It seemed as if their dream of flight was going to die.
A gentleman drove up, stepped out of his chauffeur-driven limousine, walked around inspecting the airplane, which was being built in the open. The gentleman stopped, started a conversation with Igor Sikorsky, and Igor Sikorsky eventually tells the story that this gentleman sat down and wrote out a check for $5,000, handed it to my father and said, "I believe in you, I trust you, pay me back when you can, go, start building your airplanes." The man's name was Sergei Rachmaninoff, and it was this great pianist and composer who gave Dad his start in America.
The plane Rachmaninoff's contribution made possible was the S-29A, a twin-engine, all-metal transport that was the forerunner of the modern airliner.
It gave him the intellectual freedom and the financial wherewithal to produce the aircraft that a visionary could see, and in the process produced very successful aircraft.
He followed with other designs and started building a reputation as a visionary. In 1930, he gave a newspaper interview in which he described a glimmering future of sleek metal aircraft carrying hundreds of passengers from continent to continent.
Igor Sikorsky predicted in this newspaper interview that New York would be the center and the hub of one of the most busy airline services. Giant all-metal airplanes, sleek all-metal airplanes carrying hundreds of passengers would be taking off every hour on the hour for the far corners of the world.
At a time when most aircraft were still made of fabric stretched over a wooden frame, he talked about pressurized cabins and jet engines as if they were something he had already tested.
To get metaphysical, my father also believed very strongly in intuition, in a sixth sense, which sometimes came to you in a flash in the middle of the night. Sometimes it arrived very, very slowly after you'd been chewing on a problem for a while.
He had his first big hit with the S-38, a flying boat that Pan American Airways used to open new commercial aviation routes to Central and South America. That success brought in other investors, including United Aviation, which was then a major producer of aircraft. And for the first time since leaving Russia, Sikorsky had the money for large-scale design and construction of aircraft. Though still fascinated with helicopters, his business grew because of his success designing fixed-wing aircraft. Among those who visited the Sikorsky factory was Charles Lindbergh, just returned from his flight to Paris. Sikorsky and Lindbergh found in each other kindred spirits. They were both intellectually restless, at the same time cerebral and instinctive. Both had clear visions of aviation as an everyday experience, pioneers who longed to make their field of endeavor commonplace to the point of being boring. Even their differences seemed complementary. Lindbergh looked at aviation from the point of view of a pilot. He wanted to open the world to aviation, and he traveled ceaselessly, charting routes for others to follow. Sikorsky, on the other hand, saw aviation as an engineering problem. To follow the routes Lindbergh was plotting, a passenger plane would have to have a certain range, be able to reach a certain altitude, and carry a certain amount of fuel.
He'd spent a lot of time in the dark listening to music, thinking, and he felt that he could almost see into the future, so to speak. Again, he was a very mystical, very spiritual man, to see what the needs would be, where his ideas could be applied to the betterment of mankind. And I think his particular genius came in his ability to take technology and apply it to the human need.
Lindbergh, Sikorsky believed, was the greatest pilot in the world. Sikorsky, Lindbergh said, was the most gifted aircraft designer he had ever met.
Dad had a great deal of respect for Lindbergh because there's no doubt about it, man knew a great deal about aviation. And in fact, it was this gentle teamwork between Lindbergh and Sikorsky, the mutual respect that they had for each other, that was absolutely wonderful to see in action.
The first plane they collaborated on was the S-40, a flying boat larger and more dependable than any other. Lindbergh was working for Pan American Airways, setting up airmail service to the Caribbean, which was then a sea of islands without landing strips. Tying them together with aircraft posed problems that seemed even to Lindbergh nearly insoluble.
I was growing up at that time. I was a small kid, but I was privileged once in a while to sit in a corner of the dining room when these two giants would discuss the growth of aviation, the need for higher speeds, the inevitability of higher wing loadings, and yet the improvement of our knowledge of aerodynamics, which would still keep landing speeds down while the cruising speeds would go up. Now, it was a wonderful way to grow up because you may have gotten a formal education in high school and in college, but if you were an aviation buff, as I was, those evenings listening to Charles Lindbergh and Igor Sikorsky were the greatest aeronautical academy that anybody could dream of having.
It was the beginning of one of his most productive periods. Working together with Pan Am and Lindbergh, he designed a series of amphibious aircraft that formed the famed Pan Am Clipper fleet. He had in his career played a key role in two separate revolutions. In Russia, he had pioneered multi-engine aircraft, which became the first dependable air transports and long-range bombers. In the United States, he had designed the flying boats that had made intercontinental air travel possible. The Pan Am Clippers shrank the world, putting every place in the world within a couple of days' travel of every place else. So, with his company doing well and his reputation secure, he returned to his first love. In the middle 1930s, Igor Sikorsky dug out 30 years of notes and sketches, dusted off a handful of patents, and went to work on the helicopter. Before Igor Sikorsky got seriously into helicopter development, there had been a number of more or less successful experiments in vertical flight. Some could fly but not hover, and others couldn't fly at all. Overcoming the torque of a spinning main rotor and still being able to maneuver was such a big problem that it led many to believe that a practical helicopter would never be developed. Sikorsky, however, believed passionately that the helicopter would work.
He was not interested just in engineering and technology. The primary reason he developed with the helicopter was to rescue people, to save people's lives.
As he worked and reworked the design of his helicopter, Sikorsky said over and over that if a person was in danger, an airplane could fly over and throw flowers to him, but a helicopter could come in and perform a rescue. Working at his Stratford, Connecticut factory, he and his team, still made up largely of Russian immigrants, built the VS-300. Ungainly by modern standards, the 300 was little more than a framework to support the engine and rotor. On September 14, 1939, Sikorsky sat down in the VS-300's pilot seat for its first flight.
When he climbed into this machine for the first time, he said it was a beautiful chance to relive one's life all over again, to design a new type of flying machine without quite knowing how to design it, build it without quite knowing how to build it, and then you climbed aboard and you opened up the throttle and you tried to teach yourself to fly at the same time that you were the test pilot in charge of the helicopter.
Sikorsky carefully, slowly lifted off, learning to fly the helicopter as it rose. He went only a few feet off the ground, hesitated a few seconds in midair, and settled gently back to Earth. The world had its first working, practical helicopter. While Sikorsky thought the helicopter's future lay in rescue, the first American military man to get a look at the VS-300 instantly recognized its battlefield potential.
People began to realize the idea that we can move large numbers of troops, we can attach weapons to these, and so the United States Army, for example, their aircraft, their helicopters, and these are very, very important for maneuver of the Army units.
In 1942, while looking for aircraft that could be developed to fight German U-boats in the North Atlantic, two Coast Guard officers paid Sikorsky a visit. They watched in awe as Sikorsky lifted 25 feet off the ground, lifting a second man below on a suspended rope ladder. In their report on the test, they said Sikorsky's machine had many advantages over the blimps the Navy had developed for anti-submarine warfare. They recommended the Coast Guard buy 3 or 4 for testing, but the Navy balked at the $250,000 price tag. When the officers pointed out that helicopters could serve a search and rescue function, the War Department replied that the Navy was not interested in life-saving. They just wanted to get on with the business of killing the enemy.
I think he was aware that inevitably, sometime sooner or later, it would be used as a military instrument of war. But that he said, was not the fault of the helicopter, because for every single person that it killed, he insisted quite logically that it probably saved 100.
For the remainder of his life, Sikorsky designed and built helicopters. From the R-4, the first mass-produced helicopter, to the UH-60 Blackhawk, the machines he and his company designed and built rewrote the rules of aviation, of warfare, and of search and rescue.
Whenever one talks about Igor Sikorsky today, it is the helicopter that he is remembered at. And that's, I think, justifiably so. It is the last and, in many respects, the most important piece of equipment that my father invented and left for mankind. When I asked him about it, he said that he had a number of favorite aircraft. And obviously the Grand, the first prototype 4-engine aircraft, was one. The flying boats were another one. But I believe also he himself felt proudest of his achievements in designing the helicopter.
The Sikorsky Blackhawk has been a reliable warhorse for the U.S. Armed Forces. For over 35 years, it has been leading the charge into hostile territory, from the deserts of Iraq to the mountains of Afghanistan. The rhythmic pulse of its blades are both a signal to wounded American men and women that help is on the way, and a warning to enemy forces that trouble is on the horizon. After decades of upgrades, they remain some of the most sophisticated aircraft in the world. But is it possible to create an even more advanced machine using today's technology? What if the world's rotorcraft manufacturers started with a blank sheet and reimagined the helicopter from the ground up? In some ways, Vietnam was a helicopter war. Helicopters were key to moving troops and equipment in and out of hostile territory and airlifting the wounded to safety. They also fearlessly charged into battle, serving as spotters or leading the assaults themselves. The Bell UH-1 Huey was a vital member of America's stable of helicopters. Though designed as a transport, it would be pressed into many roles under the pressures of war, from rescue craft to flying gunship. Though it was a noble warrior, even with continuous upgrades, it was still largely based on technology from the 1950s, and by the late 60s, the U.S. Army was looking for an upgrade. Their quest for a replacement would lead to the birth of the Black Hawk.
The Black Hawk started out as a replacement for the Bell UH-1 Huey, which was widely used in the Vietnam War, in fact became iconic of the Vietnam War. And they took all that experience they had learned in the Vietnam War and they applied it to the requirement for what was then called the UTTAS or UTAS, which was Utility Tactical Transport Aviation System, in the early 70s.
3 of today's leading rotorcraft manufacturers took up the UTTAS challenge, designing the heir apparent to the Huey: Bell Helicopter, Boeing Vertol, and Sikorsky. After evaluating the proposals, Boeing and Sikorsky were given the go-ahead to construct prototypes. An intense competition between the two designs followed, with the Sikorsky Black Hawk ultimately winning the crown from the Huey. It wasn't long before the Black Hawk was building its own name as a legendary rotorcraft.
Really what made the Black Hawk the helicopter it is they took all that experience they'd learned in the Vietnam War about survivability, about crashworthiness, about the ability to carry a complete team of soldiers, not have to have several helicopters to carry them. And that really made the Black Hawk the utility machine it became.
The Black Hawk design has proven to be so robust that it's been adapted for the Navy as a Seahawk. It's also used around the world with many different countries. It's one of the most ubiquitous helicopter designs of the 20th century.
Extensive modifications have kept the Black Hawk at the forefront of technology, but it is still based on a 40-year-old design. As tough a warrior as the Black Hawk has been, after participating in 2 desert wars, there were questions about its suitability in future air battles. Has the Black Hawk finally reached the end of the line?
Even though they've gone from the UH-60L to the UH-60M and they've got bigger engines and a bigger rotor, they now find themselves operating in high temperatures and high altitudes, and they realize they don't have the performance they thought they had. Not only that, but they're being shot at again and they're crashing in sand and other problems. So they really come back from Iraq and Afghanistan realizing that the helicopter that's done them well for the last few decades is not going to do them well for the next few decades. So they start to lay out their plans for a replacement and to take all that experience they've learned from fighting in the desert and fighting in the mountains and apply it to a new helicopter that they think will be more suited to a future war that is not on a flat, grassy, green battlefield somewhere, but is going to be, they don't know where. And that's the point. They want a helicopter that will fight wherever they end up fighting.
The U.S. Army's FVL, or Future Vertical Lift program, was conceived to explore replacements for not only the Black Hawk, but for the rest of its aging stable of rotorcraft. The new breed of rotorcraft will not only use the latest breakthroughs in technology, they will also share common parts, making building and maintaining the fleet a more economical process. JMR, or the Joint Multi-Role Helicopter Program, is a competition to evaluate the technologies that will go into FVL helicopters.
So JMR is being led by the Army, but it's developing technologies in concert with the other services for the Future Vertical Lift program. In the competition, both Bell and Carrier aircraft were looking at tilt rotors, and AVX and Sikorsky Boeing were looking at a compound helicopter. Now, each company had a very different take on these approaches, but the key was high speed and long range.
The goal they've set is 230 knots. 230 knots is somewhere between 50 and 100% faster than a Black Hawk. A Black Hawk can do 170 knots. It never does 170 knots. The most it'll do is 150 knots. In hot and high, it'll only do 110 knots. So when you talk about 230 knots, you're talking about, in effect, twice as fast as the Black Hawk. And then you're talking about adding the range so they can go twice as far, twice as fast. So that's sort of like a threshold the Army said we want to look at. We want you, industry, to show us, the customer, that we can afford to go twice as fast, twice as far. That's what joint multi-role is all about. It does not mean that the Black Hawk replacement will fly twice as far, twice as fast as a Black Hawk, because the Army might still decide it can't afford to go twice as far, twice as fast.
The JMR competition saw two relative newcomers in the rotorcraft world take up the Army's challenge to go twice as far and fast. The AVX Aircraft Company and Karam Aircraft, a company founded by Abraham Karam, the father of the Predator drone.
So AVX and Karam both had really interesting approaches to this mission requirement. AVX was looking at more of a lower cost version of a high-speed compound, where Karam was looking at a really advanced tilt rotor, which they believed could hit much higher speeds and much longer range with what they call their optimal speed tilt rotor, OSTR.
Bell Helicopter, manufacturer of the V-22 Osprey, put forth a similar-looking rotorcraft for JMR. A byproduct of its tilt rotor design is phenomenal power.
The Bell helicopter design, it's actually a 280 knot machine, which is much faster than the Army says it needs. But that speed actually falls out of the amount of power that it needs to take off and land vertically. So they put these two 5,000 shaft horsepower class engines on it to be able to take off and land vertically at the sort of 30,000 pound gross weight that the Army thinks this thing is going to weigh, which is about 10,000 pounds more than a Black Hawk. And then once you put those rotors down into cruise mode and it becomes a turboprop, you've got the power on board to go 280 knots, maybe even faster. So Bell uses that as an advantage when it does all of its tactical calculations about how many V-280s do you need to cover an area of responsibility, a battlefield. They've got this enormous speed advantage, and speed equals range in this case is how far can you go in a set amount of time. So to them, they use speed as an advantage.
The team of Sikorsky Boeing have a head start in their Defiant, conceived for JMR, having created two advanced compound helicopter prototypes with their own funds.
Sikorsky Bell, they've demonstrated with the X2 technology demonstrator that they can go to about 260 knots with this coaxial rotor, rigid coaxial rotor design. The Raider, which is the slightly bigger prototype they're building, they're aiming for about 240 knots. They think it'll go faster than that, but they're aiming for about 240 knots, clean, with the weapons tucked away. 220 knots if they have the weapon doors open and the weapons deployed. JMR, they're saying 230 knots. They think it will probably go as fast as 270 knots when it's clean. These are fast machines.
The Army narrowed the field of competitors from 4 to 2. It's not that surprising that Bell Helicopter and Sikorsky Boeing were the last two left standing. Though all teams had something unique to offer, the Army may have chosen to make a safer bet by siding with the larger companies with a longer proven track record. The great difference in their approaches allow the Army to evaluate two completely different systems.
The approach from Bell is a tilt rotor. The tilt rotor tends to be inherently better at cruise and more efficient for loiter because it has a wing. It can use wing-borne flight and use aerodynamics to keep the aircraft aloft rather than the helicopter's rotor pushing down. A compound helicopter, which it basically takes a helicopter and puts a pusher propeller on it to make it go faster, and it can also go farther because it's not using the helicopter rotor to do both lift and forward thrust. And that's what Sikorsky and Boeing are looking at.
The origins of Sikorsky Boeing's choice of design go back to the early 2000s, when Sikorsky was working on its own. The success of the Black Hawk enabled them to take helicopter technology in new directions.
Sikorsky was making a lot of money on building Black Hawks by the 100 for the Army. And they basically decided to start putting some of that profit into demonstrating technology for what they thought the next generation of rotorcraft would be. Now, they went off and they looked at all the possibilities. They looked at tilt rotor, they looked at variable diameter tilt rotor, they looked at other possibilities, and they came down on a design they'd actually done before.
In the early 70s, Sikorsky developed the XH-59. This was an experimental machine designed to test the advanced blade concept that is using two rigid contra-rotating rotors. Russian manufacturer Karmov had already produced several successful coaxial rotor designs. The concept had great potential, but it had a fatal flaw.
It's a very efficient hovering machine. If you think about it, the rotors get two chances to bite at the air. First rotor pulls the air through, gets some lift, pushes its second rotor, pulls the air through, gets some more lift. Very efficient hovering machine, but slow because you're pushing two rotors through the air when you're going forward. So back in the late 60s, Sikorsky with Army and NASA set out to design a high-speed helicopter and demonstrate they could fly fast with this thing called the XH-59. So the XH-59 had coaxial rotors, but they were very close together. They were very stiff, so they wouldn't bump into each other, but that allowed them to put them only inches apart, which dramatically reduced the drag of the rotor system when they pushed it forward, because the rotors were close together. There wasn't a long, thin mast between the rotors. If you look at a Kamov design, several feet between the rotors. You push that forward, it generates a lot of drag. So they did this, they flew this, they did something around 260, 270 knots. But it was very complicated. It took two pilots to fly this helicopter, and it had four engines. It had two engines driving the rotors and two jet engines pushing it forward. So basically they decided that's not a good idea, and that went back on the shelf.
Though the XH-59 was overly complicated, might advances in technology make the basic concept the foundation for a new generation of helicopters?
In the early 2000s, there's Sikorsky saying, what's the next generation of rotorcraft? And they looked at all of the technology we've developed since. They looked at fly-by-wire, they looked at composites, they looked at integrated flight and propulsion control, they looked at vibration suppression, active vibration control. And they said, we can do that. We can do what we did with the XH-59, but we can do it with one engine, one pilot, and less vibration at twice the speed of a Black Hawk. So they set out to demonstrate with a thing called the X2 technology demonstrator.
So this uses a very closely spaced coaxial rotor, counter-rotating rotor, and then a pusher propeller. And they've proved with their X2 demonstrator that they could reach speeds of about 250 knots.
Very successful, done as a sort of a rapid prototype in a sort of skunk works type operation. Small team, put it together, flew it. Having shown that, they then decided to put more of their money where their mouth was, and they decided to put $200 million of industry money into building two prototypes of a light tactical helicopter called the S-97 Raider.
The X2 and S-97 Raider were not developed specifically for the JMR competition. Originally, Sikorsky hoped to replace an aging scout helicopter, the Bell OH-58 Kiowa.
The S-97 currently is not part of the future vertical lift family of aircraft. It's a company-funded demonstrator that they would like to have purchased by the Army and other services as a light attack helicopter. The Army has had an outstanding requirement for decades now to develop a new attack scout helicopter. It was going to be Comanche, but then after billions of dollars and a couple decades of development, they ended up having to cancel that program.
Sikorsky hoped by building and flying the X2 and S-97 Raider, the Army couldn't help but purchase their design for a new high-speed scout helicopter. It was a gamble that didn't work out as Sikorsky had planned.
Well, it went a bit awry. The Army sort of lost direction, really. And then eventually, when the budgets got tight, the Army decided it couldn't afford an armed scout helicopter. But Sikorsky just kept going, and it will build and it will fly the S-97, and they'll demonstrate it to the Army. And they're hoping that, you know, when budgets ease off and the Army realizes that it really does need a scout helicopter, they'll be there and ready when they come back. And there may be other requirements. The special operations folks have still got to replace their Little Bird helicopters, so they think there's something out there that eventually they may come. Meanwhile, the S-97 Raider is a good stepping stone towards joint multi-role and future vertical lift. It's significantly bigger than the original technology demonstrator, but it's significantly smaller than the joint multi-role. So joint multi-role takes that next step in size.
Sikorsky has a larger version of the S-97 in development, especially for the JMR contest, known as the Defiant. This is a medium-sized helicopter and a Black Hawk replacement. JMR will ultimately call for 4 sizes of helicopter to be produced to replace 25 helicopters currently in operation. Sikorsky's proven ability to scale its compound design could be a key advantage.
If you're in the rotorcraft, the biggest risk you face in designing a helicopter is scaling. Something works at one size, you then go and make it another size, and all of a sudden a whole bunch of problems turn up that you didn't realize. So if you're going to convince the Army that high speed is doable and affordable, you've got to get rid of all the areas of risk that you can. So scaling this up from the X2 technology demonstrator to the S-97 Raider and now to the JMR TD allows Sikorsky to remove the risk of scaling.
Sikorsky boosted its odds of success by partnering with another giant in aviation and one of its great rivals.
Along the way, Sikorsky surprised us all by teaming with Boeing for this. Up till then, everybody had expected that Boeing would bid on its own. Not because they really had any incumbency on the Black Hawk. That was Sikorsky's business to win or lose. But because the Army was saying that eventually either the actual vehicle or certainly the technology that was in the Black Hawk replacement would be the basis for the Apache replacement. So Boeing was looking, saying, we're the incumbent on Apache, we've got to protect our turf, we've got to be in on JMR and FVL, because if we're not, and then the Army does decide to take the dynamic system or the entire airframe and repurpose it for the attack mission, we'll be out of the running. So Boeing was doing its own work, and Boeing actually was heading towards a tandem rotor design, because if you look at Boeing, they do a lot, Chinook, very successful. And the mission for the Black Hawk replacement drove Boeing to a tandem rotor. Was never going to that was not going to work. That was not going to be competitive. So eventually they decided to team. So now you have the company that's the incumbent on the Black Hawk and the company that's the incumbent on the Apache, which make up 60% of the Army's helicopter fleet, tied together on the potential replacement for all of those helicopters. They stayed with Sikorsky's X2 configuration, but Boeing brings in its composite airframe technology, its integrated avionics technology, and other things like that to help Sikorsky make this design as competitive as they can.
Though Sikorsky and Boeing made a formidable team, they faced stiff opposition from legendary rotorcraft manufacturer Bell. Bell's V-280 Valor builds on many of the lessons learned from years of research in tilt-rotor design.
Bell is describing the V-280 Valor as what they call a third-generation tilt-rotor, which makes you go, what are the other 2 generations? Second generation clearly is the V-22 Osprey. The first generation is the XV-15, the original experimental tilt-rotor that flew back in the 1970s, I think. That was an extremely successful aircraft.
The XV-15 proved the potential of the tilt-rotor system. However, when creating the Osprey, designers had a tough challenge meeting the rigid set of new requirements set by the Marines.
One of the challenges with the V-22 Osprey is it had to fit on the Marine Corps' assault ships and we have a taxi past the island. So that made the wingspan much shorter than it would have liked to have been. Then also having to rotate the wings and fold the blades, make it very compact for storage under the deck, made it more complicated.
So the V-22 ended up having the rotors are too small, the wings too small. It works, but it's a highly compromised tilt rotor. So when we come to the V-280, basically Bell goes back to the original intent of the tilt rotor and has an uncompromised design. Because this thing doesn't have to fold, it doesn't have to go on a deck, it doesn't have to go under a deck, they can make the rotor diameter what it should be, they can make the wingspan what it should be, they can take the forward sweep off that they put on the V-22, they can remove that and have a straight wing which is lighter. And then there's all sorts of other things they had to put into the V-22 so it could operate in a maritime environment that they just can remove. They don't need it for an Army helicopter.
Although Bell had a much freer hand in designing the V-280, there were still many nagging concerns about its tilt-rotor design, the foremost being cost.
Bell, as it builds the Joint Multi-Role demonstrator, is really trying to prove one major point. And that major point is they can build a tilt rotor for the price of a conventional helicopter. If they can't prove they can build this aircraft at a reasonable price, they're dead in the water.
Bell's Osprey has become a vital part of U.S. Marine operations. Its success is strong evidence of the utility and versatility of the tilt rotor. But the V-280 Valor is being constructed for the Army and for a different type of mission altogether.
One of the big things I think Bell has to prove is whether or not a tilt rotor can actually do the mission that the Black Hawk does, which is flying into a firefight to drop off troops, pick up the wounded. You're not talking about the way the V-22 is necessarily operated, which is much more of a transport role.
The V-22 has really proven itself in the conflicts in Afghanistan and around the world with its ability to get in someplace long range, get there fast, hover, land, and get out. So it's really proven itself over the last 7 years it's been in operation.
The tactics that the Marines have evolved with the V-22 to make it survivable is that it stays fast for as long as it can. It basically flies in fast with the rotors down in turboprop mode, and then at the last minute they swing the rotors up into helicopter mode, they land, they load, unload, they take off, they put the turboprops down as quick as they can, and they accelerate out of the danger zone. Their exposure is very limited. That's how they've sort of got around the vulnerability that comes with the complexity of the tilt rotor. Bell has got to prove whether that applies to the Black Hawk mission. If it's going to be hovering more than the V-22 is, it's going to be exposed to fire more.
Ensuring the safety and survival of the crew to and from the target is a key part of any rotorcraft mission dossier. A byproduct of the V-280's tilt-rotor design is an easy escape route.
Because they tilt only the rotors and not the engines, if you think about it, the V-22, they tilt the entire nacelle, so the hot exhaust comes close to the ground when they're in hover mode. In the V-280, they only tilt the rotor, and the engines stay fixed on the ends of the wing. One reason is simplicity. The second reason is so that they can unload the troops from the side doors and they can run sideways away from the aircraft, which is what they do with the Black Hawk. Whereas in the V-22, they can only go out the back door. Now, out the back door is fine, but you can't exit the aircraft as fast. You can't empty the aircraft or load his aircraft as fast if all of your troops have to go out the back door.
The V-280's side doors provide a faster means of escape than those of the V-22, but both aircraft are enticing targets for enemy fire.
It's hard to say whether a tilt rotor is more vulnerable than a conventional helicopter. It still has engines, gearboxes, rotors, all of which are things that can be shot at. It's really more a case of it's a physically larger signature to shoot at. And it's really this, can they minimize the amount of time that it's on the ground? And can they harden it? I mean, can they make sure that the rotor system can take a shot? On the V-22, they're able to minimize the exposure by the way they operate it. Where the Army may operate a tilt rotor would be very different. So it's going to be a different calculation, and that's going to be a key part of the demonstration.
The Army has a difficult decision to make, choosing between excellent proposals from Bell and Sikorsky Boeing. They are hopeful that this new rotorcraft will be instilled with one quality absent from the Black Hawk: self-sufficiency.
The Army wants whatever it buys to replace the Black Hawk, it wants it to be able to self-deploy. At the moment, if you go abroad with a Black Hawk, you either have to hop from island to island, in effect, to get somewhere, or you have to pack them up, put them in a C5 Galaxy or a C-17 and fly them. And that takes an enormous amount of strategic airlift to move all of the Black Hawks needed to support an Army division or something like that. The goal the Army has set is they want to go 2,100 miles, which is the longest leg anywhere in the world. It's Hawaii to Los Angeles, I think. No refueling, all the fuel in extra tanks on board the helicopter. So basically, when an Army division deploys, the helicopters will go out on their own and will be waiting when they arrive. That simplifies it for the aircraft designers. They've got to put the fuel in there, but it means you don't have to fold this thing up to go inside an aircraft. You don't have to take the rotors off, make it fit. For Bell, that's a big advantage because that removes one of the big problems of the V-22 is the weight of all that folding mechanism is a huge weight for the V-22 and makes it very, very relatively inefficient for a tilt rotor. With the V-280, they can bolt the wing onto the fuselage. They can go for a very simple structure. It's all composite. The V-22 is composite, but it's what people call black aluminium. If you go in a V-22 and you look at the structure, it looks like it's aluminium. It has fasteners, it has frames, it has stringers, it has all things you'd expect in an aluminium structure, but it's actually carbon fiber. If you go into a V-280, they've gone to the what you can do with composites. Big self-supporting structures, some major frames, but not lots of frames, not lots of stringers. It's basically honeycomb stiffened structure for the wing and the fuselage, which is very light and very simple to produce.
The JMR competition is more of a marathon. Sikorsky, Boeing, and Bell are building rotorcraft to test and demonstrate technology only. The actual competition to build the Black Hawk replacement is to follow.
Everybody involved gets a second chance. Not only that, but on the current plans, the Army intends in the FVLM program to fund 2 competing Y-plane prototypes. So we could have a situation where Bell and Sikorsky Boeing fly their demonstrators in 2017, go into another competition, and then fly Y-plane aircraft in 2025, and then down select to the aircraft that would be finally developed to replace the Black Hawk. So we're a long way from knowing who's won here. And it's important to remember that the Army has this second chance to choose. And also the Army has yet to decide it wants a fast helicopter. After all this, it could decide it wants a conventional helicopter because it's cheaper. After all this, the Army could decide to upgrade the Black Hawk again. It's done it from the A to the L and from the L to the M. There could be another generation of Black Hawk to come along. They're already planning to put a bigger engine in the Black Hawk, the ITEP engine. Sikorsky also has technology available to put an active rotor on the Black Hawk. I don't know whether in some dark room they've got some way of putting a coaxial rotor on a Black Hawk. We don't know. All we know is it's likely that the Army will upgrade the Black Hawk again, and it's possible they may go for a conventional helicopter to replace their FVL. They may not go for either of the fast rotorcraft.
With the Black Hawk replacement 20 years away, one has to question if the Army's timeline makes sense, and whether the technology developed in that time frame will be worth the wait.
2035 is a very long time from now, but some of that is we want to get this right. This is the first new development aircraft for the Army and most of the other services basically since the 1970s. So we want to see what is possible with the current state of the art, what we can prove, what would be possible for the next generation of aircraft.
Both Bell and Sikorsky Boeing have excellent designs and proven track records constructing rotorcraft for the U.S. Armed Forces. But who holds the edge in the competition? Perhaps Sikorsky Boeing's biggest advantage isn't technical. It's that they have the most to lose.
As we stand today, and you look at how the teams are lined up, we've got Bell on one side, we've got Sikorsky and Boeing on the other, and then we have the other 2 players, the small guys who got cut out this time round, the AVX aircraft and Karam aircraft, who may yet attract some bigger backers for the next stage. You have to say to yourself that that it's Sikorsky and Boeing's competition to lose. They are the incumbents on the UH-60 Black Hawk utility helicopter and the H-64 Apache attack helicopter. It's their business to lose. But it's also a huge market. We're talking 3,000 helicopters plus all of the export, thousands of helicopters that export customers buy. Nobody's going to let them just walk in and take that. They're going to have to prove they can do it. They have a good technology base. They've flown the X2 technology demonstrator. They're building the S-97 Raider. That configuration with the rigid coaxial rotors and the pusher propeller on the back is going to be well proven by the time they fly their demonstrator.
On May 22, 2015, a test took place critical to the future of Sikorsky Boeing's compound helicopter design. On that day, the S-97 Raider was to lift off for the very first time. Scientists and engineers gathered at the Sikorsky Development Flight Center in West Palm Beach, Florida, to scrutinize the event. They watched anxiously as pilots Bill Fell and Kevin Bredenbeck gingerly took the Raider into the air.
All right, just a few words here. So another first and a proud heritage of first for Sikorsky aircraft is now in the history books. A special thanks goes out to the entire Raider team, Kevin and I, for building this phenomenal machine.
A month after Sikorsky's triumph, it was announced that defense manufacturing giant Lockheed Martin was purchasing the company for $9 billion, perhaps bolstering its hand even more in the helicopter competition. Still, even with the success of the Raider and the added support of Lockheed Martin, victory is not a foregone conclusion. Sikorsky Boeing still have much to prove to win the next phase of the competition, as do their main rivals, Bell.
Bell has a higher hill to climb. They can offer very high performance with the tilt rotor, but they have got to prove they can build that rotorcraft at an affordable price. They've also got to prove that it can do the Black Hawk mission. The V-22 does not spend a lot of time hovering. Black Hawk spends most of its time hanging around hovering. And so the other thing that Bell's got to prove is they can hang around and hover as efficiently as a rotorcraft. Sikorsky and Boeing don't have that problem. They know that they can hang around and hover efficiently. A coaxial rotor is a very efficient hovering machine. They've got to prove that that whole combination, the complexity of having two main rotors and a propeller on the back and integrating all that propulsion with flight control, they've got to prove to the Army that that's worthwhile. So they've got to prove that it's affordable. They've also got to prove there's some interesting ways you can fly the helicopter when you've got that propeller hanging out the back. You can do flat attitude approaches. You can hang on it, point the helicopter. They've got to prove that that means something in the utility mission. It isn't just nice to have, but you can actually do some real things. So they've got some things to prove as well. But as we stand today, you've got to look at what Sikorsky and Boeing have to lose and think that they are going to put everything into winning this. Bell, it's not as existential for Bell. It's not business they now have. If they lose this, they don't lose business they already have. If they win this, they win a market they don't have. But there is no doubt that for the US rotorcraft industry, this competition for FVL, Future Vertical Lift, is the one that's going to decide who dominates the industry for the next 50 years.
It will be a long time before the shape of the next generation of rotorcraft becomes clear. Much time and money is being invested by Sikorsky Boeing and Bell to create new, faster helicopters, but the Army still might choose to go with a slower, cheaper design. Still, the knowledge gained constructing these awesome machines might still be applied to more conventional rotorcraft. As well, Caram Aircraft or AVX could make a return to the main stage and strike back with a contract-winning design of their own. All that we can be certain of is that the Black Hawk will soldier on until a new helicopter finally materializes, worthy to relieve it from duty.